Hey everyone, welcome to our second lesson on special relativity. Today we're going to get stuck into defining frames of reference. So our learning goal today is not just to define these, but know what the difference is just between a normal frame of reference compared to an inertial frame of reference. So let's get started. A frame of reference, very specifically, is something that describes a particular system of measurement coordinates. Now, these measurement coordinates aren't just in space, but also in time. Yesterday, we considered the Galileo thought experiment, where we have a person standing on the mast of a ship and dropping a ball, and from their frame of reference, they saw that ball traveling vertically downwards. But the bystander who was on the island saw the ball traveling in this parabolic path. Okay, so these are two separate frames of reference where the measurement of the ball is different. Another situation to consider is when you're driving along a road. The car or yourself in the car, all right, you could argue that you are in fact stationary and it is the road underneath you that is moving backwards. If, however, you're on the road, or you're a bystander on the road over here, you could argue that you are stationary and from your frame of reference, it is the car moving forwards. All right, so in this case, it doesn't actually matter if the car is moving at a constant velocity or accelerating. That's just defining two different frames of reference where we have two different sets of measurement coordinates. When we talk about frames of reference, there are two types. The first type is what we call an inertial frame of reference. So that's where we're traveling at constant velocity. And then we have our non-inertial frames of reference as well, which is where we have acceleration at play. So let's take a look at 4 examples. If I consider these two, A and B, examples on the top where we have a man standing on a train, it looks as though they're exactly the same picture. But in fact, I could tell you that one of these is in fact stationary according to an outside observer, and one is moving at 20 meters per second. However, from the information you've been given, it looks as though they're exactly the same. And there is actually no way to tell the difference because all forces are balanced in both of these two situations. Because both of these situations we are traveling at constant velocity with no acceleration or no external forces on the system, we call these our inertial frames. Now let's have a look down here at C and D. Now we can see that we have two different situations here. In fact, in frame C, we notice here that the handles are traveling forwards, meaning that we have an acceleration backwards here. We have a train that is slowing down. Conversely, in frame D, we have a train that is speeding up. So there is in fact an acceleration at play here, and this is very similar to what handles would actually do on a train in real life. Because these guys are accelerating and there are clearly forces at play or unbalanced forces at play, we would say that these two reference frames are non-inertial. So to put that in a clear definition, what you need to know is that an inertial frame of reference is simply a reference frame that is not accelerating. And these are the types of frames of reference that you will be working with in this physics course. So with all of that information combined with your relative velocity understanding from last lesson, you're now able to have a go at the questions in 10.2. If you have any questions, please do not hesitate to contact your teacher. Thanks, guys.